More checking to see if y'all are all getting the same answer. What'd y'all get? 13. What is that, 13? And yours is 13. 13. All right, so over here they're getting 13 point something. Are you stuck? Are y'all stuck? No? Try and see together if y'all can come up with the same answer. So you got 12 point something. They got 13 point something. You got 12.
I got 13.
You got 13. Y'all figure it out. There should be some rounding errors, but it shouldn't be a huge error. Try and figure out if your answer is not the same as your neighbor's. Try and figure out what the deal is. I'm going to write the equation on the board. Everyone should have that to start. Do you have that? Do you all have this next line? Oh, you got it? You feel better about it? Okay. Yes? Now rewriting this as a logarithm, log e 1.375 equals 0.024t. Yeah, because it's log and it has an e here, you can go straight to natural log 1.375 on your calculator equals 0.024t. And so I have to do that on my calculator. 1.375. So I'm getting on the left side 0.318 and some change. So this is where everyone's going to vary a little depending on how many decimals you want to go. I'll just stop there.
When you did n 1.375 equals, how'd you get the? Oh, we already have it right here. Sorry, never mind. Answer now.
So just in case, and just so when if y'all talk to anyone in the lab or something, ln. ln.
Oh, it's not.
It's not in. Yeah, it's ln.
Oh, gotcha.
Yeah, it stands for logarithm natural.
Oh, it makes sense.
Yeah.
Okay.
So I just don't want you to go to the lab and they're like, "What did you say?
What's in?
Your teacher didn't say anything about that." What's in? So natural log, right, of this on your calculator. Everyone got that?
Yes.
And then divide both sides by this,
Okay.
by that. So divide that by 0.024. 13.27-ish. 13.27-ish. So T is about 13.27 and some change. So about 13 years at that interest rate. All right. You feel like y'all understand? All right. So why don't I give you a couple of problems for you to do for homework? We still have time. Don't get too excited.
So you want us to print it in?
So I'm getting in trouble because I'm not collecting it. Look, here's the thing, and I told y'all this in the beginning. This is college, right? So homework is like you need to do it just so you're preparing and practicing and so you're comfortable for an exam. I don't feel like I should have to collect it to make you do that. You know what I mean? So I expect you're going to do it, and that's it, pretty much. So
No, it's because, one thing why I asked, because then I don't have to tear out a piece of paper. Because, like, if I
Yeah, I
do
know.
homework and I put it with everything else, then I have to tear out that paper.
I got you. I understand. No, and I wasn't replying to just you. I'm just saying in general, that's the way I look at it. Like in my other classes that I teach, math classes, I don't collect any homework. None, zero, right? Because you got to do homework, right? To do, at least in math, you got to practice, right? So what I'm going to do is I'm going to give you a mixture of problems. I'm not going to tell you, like this is going to be a mixture of stuff from last time and stuff from today. So you're going to have to identify in the wording of the problem if you're doing what we just did today or if you're doing what you did for homework.
Is there workbook problems that we can do at home?
In the packet, are you saying in the packet? I can go look to see if there's some in there and what page. I'll look to see, but I don't think they're going to match exactly like this. So I want to try and be consistent with what I'd ask for you to do on the test, right? So let's say for homework, how about I do this, trim down on the words here. How about if I just tell you what A and P and R and T are instead of all the wording? Is that okay with you? And that way you can just get down to like the formula. Okay, so for problem number 1, I'm going to tell you that you're going to put $4,000 into an account. The interest rate is an incredible 5.2%. You're going to leave it in there for 5 years. And I want to know how much is there at the end. Does that make sense when I'm talking through this? $4,000 goes in. Here's the interest rate. How much time? Now how much is going to be there at the end? Second question, you're going to put $7,000 in, right? Your interest rate is, let's go with 5.2% again. And I'm going to tell you the amount at the end I want to be $10,000. So in my first problem, I actually made it very clear what you were solving for, right? Mm-hmm. Here, I'm just providing you the information. You've got to figure out what you're solving for there. Third one, let's go with, start with $2,300. You're going to end with $3,200, and the time you want for that is 7. Fourth one, you're going to start with $1 million. No, let's go $1 million. $1 million. Interest rate is 7.25%. And the amount at the end is that. All right. Yes. Yeah, let me go one more. Sorry. One more.
Or we just leave it even.
You know what? Here. This is going to be a challenge problem, and we'll talk about it next class, all right? So, if interest rate is 5%, how long to triple your money? Now, again, this is a challenge problem. I anticipate some people will have trouble with that, but it's something we can start class with next time, and I can discuss that problem. All right, everybody got your picture or wrote it down? All right. All right, I'm ready to move on. Are you all ready to move on? All right, we are going to do a major shifting of gears now. Okay, major shifting of gears in this class. We are pretty much done with all the different types of functions that I want to look at. So we're going to go back to something. Recall linear equations in two variables. We studied this a while back, something like this. That's an equation, right? It's linear because both of the variables have a 1 on them. And it's got two variables in it, right? Do y'all know what this looks like? If I asked you to draw this,
Yeah.
what is it? 2 points. Well, you need 2 points, and then you would draw a straight line, right? So this is just a line, right? This is just a line. Let's see. If I ask you to graph it, there were two different methods to do it. The two methods I showed you, the intercept method and then the slope-intercept. Exactly. So let's do the intercept method. How would you find the x-intercept of this? Set y to 0. That becomes 2x equals 12, which means x is 6. Am I going too fast there?
No.
That's all right with everyone? To find the x-intercept, you set y to 0, which kills it off. You get 2x is 12. Solve for x, divide by 2, you get 6. So that means on my x-axis, 1, 2, 3, 4, 5, 6, there's my x-intercept. And then the y-intercept, you set x to 0, right? And when you set x to 0 there, you get 4y equals 12, and you get y equals 3. So we've done this before, right? 1, 2, 3. 3 on the y-axis, draw a dot. And then you come in here with a straight line, right? And you connect those two. And when you draw this line, you need to remember that this line is actually just an infinite number of points, isn't it? It's just an infinite number of points. And that each point on that line is a solution to this equation. So these are 2 points that solve that equation, right? This point right here is the point 0, 3. This is the point 6, 0. If I plug in 0 for x and 3 for y, this will be true. If I plug in 6 for x and 0 for y, this will be true, right? 2 answers out of an infinite number of them. Right. We all feel comfortable with that? At least remember seeing it? Okay, now what we're going to do is not this. We're going to do what is called a system of linear equations in two variables. A system of linear equations in two variables. Bye. All right, take care. This is going to be the most exciting thing you're ever going to see in your life. No? Okay. All right, ready? So a system of linear equations. I'm going to write that equation down again. And now I'm going to give you a second equation. Not this one, something different. I've given you two equations, right? 2 equations. Each one of these equations, if I ask you to graph them, right, that's a line, isn't it? And this should be another line. And what I'm asking is, can you find an x and a y that make this one true, and an x and a y that makes this true at the same time? In other words, can you find an x and a y that makes both of those equations true simultaneously? Because like right now, would 0, 3 work in this first one?
Yeah.
0, 3 works here, doesn't it? But does 0, 3 work here? No. Does 6, 0 works in the first one, doesn't it? Does it work here?
No.
6, 0.
Yeah.
It does, doesn't it? See, 6, 0 is one that works in both. But how do I know that, right? I'd have to check it. So what we do is we put a brace on the outside like this, and that tells you, this brace tells you that we want you to try and find an x and a y that solves both of them together simultaneously. And this is what we call a system of linear equations in 2 variables. So think about it geometrically. Geometrically, this is a line, isn't it? And we just drew it over there. It looks like this. And then this is a different line, isn't it? And I draw that somehow, somewhere, right? I'm just going to make it up. I don't know. Actually, do I know? I do know. It's going to go something like this. And what should happen, as long as these 2 lines are not parallel, these 2 lines should what? As long as they're not parallel, these 2 lines should cross. And guess what? The point that they cross at, whatever that is a point on both lines, which means it is an x and a y that solves both of them simultaneously. Right? Do you all agree? So if somebody gives you 2 equations with 2 unknown variables, you need to realize that these are just 2 lines, and we're trying to find the point of intersection of those 2 lines. The question is, how do we do it? Right? How do we do that in general? But do you at least understand what we need to try and achieve? Yes? So how do we find that? Well, that is called solving a system of equations. There are 2 methods to do this. The red is really hard to erase. Right, so this right here is a system of linear equations. There are 2 methods to solve this. The first method is called substitution. And the second method is called elimination. And I'm not partial to one over the other. I always tell my students, do the one that you like the most, right? Do whatever you feel more comfortable with. And it seems like every time I've taught this, every class is different. One class will be like, we love substitution, let's just do that. And others will be like, no, elimination's better. So I don't know what you're going to like better here. I'm going to show you both ways. I don't care on a test. I'm not going to tell you you must do this. You just need to be able to get a solution, all right? So right now, I'm going to try and find the answer. Now, as long as these lines are not parallel, right? As long as these lines aren't parallel, how many answers should we have? Could we have more than one? If the lines are not parallel. So if the lines aren't parallel, we should have 1 and 1 only, right? Unless it's the same line, then, but I wouldn't give you that, right? If it's the same line, then every point is the same. But as long as they're not parallel to one another, then there should be a little tilt. They should hit at 1 point only. So we should only have one unique answer. So ready for substitution? The way we do substitution is, now I don't like writing steps on these. If I write the steps out, I think it's confusing to students. When I try and write the steps, I think it's better if you just see me do the example. So the first thing I'm going to do for substitution, I will kind of sketch the method. I'm not going to just, but you know, like when we were sketching functions, I gave you all the steps on how to do it. It's not going to be like that. It's going to be more of an outline, a skeleton outline. So what I'm going to do to start substitution is I'm going to look at these 2 equations and I'm going to pick one. All right? I'm going to pick either one, my choice, completely up to me. I'm going to pick one and I'm going to solve it for either x or y. Okay? So I'm going to pick one, solve for x or y. Now, when I look at these, to me, the second equation looks the best. And it looks easy to solve for x because there's x right there. I can just move this y over. Do you all agree? So let me do that. So I'm going to take x minus y. That's the second equation. And I'm going to solve for x. To solve for x, I add y to both sides. And I get x is equal to 6 plus y. Right? Okay, that's the first thing I did. I picked one of the equations, and I solved it for either the x or the y. I chose to solve for x. Now, the next step is the substitution step. What I do is I take the other equation. I'm going to run out of room here, but the next sort of step is to take the other equation and then plug in what we just got. Plug in what we just got from the previous step. So the other equation is 2x plus 4y equals 12, right? There it is. That's the other equation. Take that other equation and plug in what we just got. Well, what did we get?
6 plus
X was 6 plus y. So I'm going to replace this x right here with 6 plus y. So be careful here. You got to do 2 in parentheses. That x is 6 plus y plus 4y equals 12. So I've replaced this x with 6 plus y. And now when you look at this equation, notice that we only have one variable left. You all see that? There's only one variable in there, y. And we're going to solve for it. So now not the last step, almost last step. Now in this equation, we want to solve for the variable. So let me distribute the 2 through. 12 plus 2y plus 4y equals 12. What can I do on the left side?
You can add 4y plus
2y and 4y become 6y. And then what else can I do?
You can
Put those.
subtract 12.
I can subtract 12 on both sides. And so when I subtract 12 there, it goes away. On the right side, 12 take away 12, I get 0. And then y must be what? Divide by 6. Right, you get y is 0 divided by 6 is 0. All right, let's run through this again real quick. We had system of equations, right? 2 equations, 2 unknowns. What I did first is I picked one of them. I picked the bottom one. I solved for x because it looked easy. So I moved the y over, solved for x. Now I took the other equation that I didn't pick, wrote it down, and then replaced the x with what I just solved for, right there. Then I'm going to solve this for y. So I distribute the 2 through, get this equation, move things around, and got y is 0. Last step. I know y is 0. Now I'm going to substitute that answer back in to get the other variable. So what I mean is that we know what y is now, don't we? And back, we still need to know what x is. But back here, remember we said x is 6 plus y? I'm going to put it right there to figure out what x is. So I use x equals 6 plus y, but I know that y is 0, so x equals 6 plus 0, so x is 6. So as an answer, I could say 6, 0 is a point, right, on the graph where those two lines hit each other. I'm going to do one more, and then I'm going to give you, I'm not going to show you elimination yet. We'll do elimination next class. We're going to stick with substitution. Any questions on this, though? You see another one? One more? I'm going to keep things nice for right now. No fractions, no decimals. So the instructions here are to solve this right here. Solve 3x minus 2y equals 6. No, hold on. Negative x minus, we'll go plus 4y equals 1. Okay. I would like to know the x and the y that make both of those equations true at the same time. So first step, we're going to do substitution. First step is to what? Pick one of the two. Which one would you rather be solving for a variable on? Bottom one? And what do you want to solve for, x or y? You solve for x? Yeah? So I'm going to take this bottom equation right here. Negative x plus 4y equals 1. Pick that one. Solve for x. How would you like to solve for x? Do you want to move the 4y over?
Yeah.
Yes, and then that's going to give you negative x equals 1 minus 4y. Be careful here. I made this one tricky with that negative on the x on purpose. You divide negative 1 on both sides. Yeah, leave the x, just you got to change the signs. So if I divide by negative 1 here, negative 1 there, negative 1 here, it becomes x equals negative 1 plus 4y. In other words, the signs of everything changes. Everything that used to be negative is positive. Everything that used to be positive is negative. Are we good on that? Okay, so we picked one of the two. We solve for one of the variables. Now, pick one, solve. Take the other equation and plug in what we just got. So let's take the other equation. The other equation is 3x minus 2y equals 7. And I want to replace what? X with that. So I write 3. Do I need a parenthesis? Yes. Negative 1 plus 4y minus 2y equals 7. So I've replaced the x with what I just got. And now I'm going to solve that equation for the variable that I see. So I'm going to solve for y. Distribute here and here. Negative 3 plus 12y minus 2y equals 7. 10y. Negative 3 plus 10y equals 7. Add 3 to both sides. 10y equals 10. Divide by 10. Y is 1. Okay, y is 1. Great. Now that you know what y is, you go and get x. How do you get x? Plug it into where you solved for x, right? So to solve for x, we write x is equal to negative 1 plus 4y. But y we just said was 1. So we're doing negative 1 plus 4 times 1. That's really negative 1 plus 4, which is 3. X is 3, y is 1. All right. So I'd like to add 2 more problems to your homework. All right. 2 of these, just so you can practice with it. Let's go ahead and put those up. And then after I've got that up, you can go. Just make sure you practice these, because I'm going to move on, to the next thing, next class. So For homework, again, for your own practice, try, let's go with 5x minus 2y equals 3, and then negative 7x plus y equals negative 6. That's the first one. And then the next one, 3x minus 5y equals